Going live. You're live. Right, this is going to be a very quick and nice stream. I do think, because we have a beautiful case of a very common failure mode here. I just had to show it before I fix it. It's going to take a super short amount of time. So what we're dealing with here is a board from a big industrial device. It's dealing with some kind of magnetization for some big motor type thing, and the customer's complaining that it works for a while, then it starts struggling, and finally the motor loses magnetization and the system stops working, and replacing this module remedies the issue. So I know a fair bit about this, like general system these belong to. I know the power supplies are unreliable, but when that happens you get different symptoms. So we're probably dealing with something rather specific to this module. And we have a big heap of power resistors, which we can see have been running warm because they have changed colors over time. I can also tell from looking at the components, this has been serviced before, maybe by me, because the capacitors in the power supply have been changed. We've probably swapped some stuff there, so the power supply should be in good order. So let's have a look at the power resistors, because we have, it's one of the most graciously failed solder joints I've ever seen in my life. Let's get this in camera with my amazing microscope setup here, so I can show you what a really failed solder joint looks like. And of course that's not going to play ball without adjusting this thing down a little tiny bit. Let's see, there we have it, and adjust brightness for the most beautiful shot. That is such an amazing example of a failed solder joint. It's absolutely gorgeous. So if you don't know what you're looking at, we can very clearly see, where am I, that we have a crack forming right here. This whole area is cracked, and we are when you see big cracks on solder joints like this, you usually see thermal issues where the product changes temperature, and that changes how it behaves. And we will have cracks like this on most of the solder joints on these resistors. Can I maybe get it just a little bit better? Yeah, there you go, right in the light. That's just, look at that crack. It's amazing. So if I take my pliers and just grab onto this resistor and rock it back and forth a bit, look at that. Such mobility like that is no good. A good solder joint will not allow that kind of movement. I could just keep doing this all night. I'm not applying much force. I'm literally just rocking it ever so slightly back and forth. Probably if I just take my finger on top of it, we can do the same thing. So with the symptoms described, probably thermally induced failure sounds very likely. It's changing how it behaves depends on for how long it's been running, i.e. how hot it is. If we fix this, it's gonna work fine. So let's just do that. I've got the big tip on the soldering iron. I think we're probably gonna suck the original solder out, because I think this is new enough to use leaded solder, which is not very good to mix, unleaded solder, sorry, which is not very good to mix with leaded solder if you can avoid it. And since these are expensive things, and any downtime is even more expensive, we don't want to take any chances. So let's get at it. I'm not sure how good of a stream it's going to make just resoldering a bunch of stuff. We're not going to be doing it under a microscope because that's just getting in the way. But maybe the back cam can do a decent job showing this stuff off. Which one is it? There we go. Now let's use the optics there. Beautiful. Gorgeous. So we're going to be doing a lot of sucking and soldering today, that's for sure. It just makes me so happy to see issues like this crop up. It's just so much nicer than those difficult issues, you see. Ah shit, I should have melted that under the microscope actually so you could see how it's melting in sections. Maybe we can do that with another one. Do I have any? Let's see, do I have any which have just as bad cracks as that one? I think the next one down actually has that. So let's get back to a microscope and give you guys a look at how it looks when you melt the solder on a really badly cracked solder joint. Is that one of them? Is that the one I want? Where are we? I'm confused. I'm so confused. We're not where I want to be. Jeez. There we go. There we go. That's where I want to be. Down by her legs. Oh, that's way too zoomed in. This one doesn't have as much of a obvious crack, but it still has a big crack. Ah, yeah. That one is actually more mobile than the first one. So let's see what happens when we put the soldering on to this. What you're going to notice is there's so much stuff in between the PCB part of the solder joint and the component leg part of the solder joint that one is going to melt before the other. So it's much easier to heat the component leg in this case, so I'm just going to do that, and you will notice that it's not going to melt the solder on the PCB right away. So we're adding heat. That component leg is hot enough to be melting solder. I can see it melting on one side of a crack, and now it's moving down to actually melt it at the bottom of a crack as well. And if I were sloppy, I'd just leave it at that and we'd call it a fix. But I'm actually going to suck away the solder from this just to give it a high percentage of leaded solder. And people are showing up in the chat. Hello, hello. I'm too busy being excited about this device to even read the chat right now. A guy with a Russian name says, hello, most popular streamer I've ever known. You do not know many streamers. Then we have a grand total of 30 viewers, and that's doing okay by my standards. Let's see if this is going to play ball. The desoldering pump is so big and fat. That's getting rid of some of the solder. Is it actually going to fit? Oh, it's not going to fit down there. Whoops. We could just remove the resistors and empty the holes and then solder them back. Let's see if that's feasible, because I really would like to get rid of the original solder to make this. Oh yeah, they're very easy to remove. If you have enough solder to get any heat into the board, that is. There we go. This actually runs so hot that we can't see the values of them. We'd probably be clever to check the value of at least one of them to make sure it's not completely horrible, since we're going to have to take them off anyway. So I'm just going to multimeter this guy, see what we have. $54 ohms. Let's see what these guys measure. They're probably going to measure. Yeah, they're kind of in parallel-ish. Let's see, we have 1, 2, 3, 4, 5 in parallel. And that measures 10.7 ohms. And we have 4 in parallel there. So that's going to measure a bit differently. 14 ohms. Yeah, that seems sane to me. They're probably all identical as well. I would not expect there to be any difference between them. Well, let's just take them out one at a time and make sure there's no difference, so we don't actually ruin this board by installing them in the wrong locations. So there's not going to be any more nice high-tech diagnosis stuff in this video. We're just going to be soldering resistors, having a jolly good time doing it, being rather confident that it's going to repair this device. Have a customer who's going to be happy again, having that machine back being profitable. 58 ohms-ish. $57.6. It's going to be like roughly 55 ohms. In fact, the entire row on each side is just hooked up in parallel, so it doesn't, as long as we don't mix the rows up, there's not going to be any difference in how we put them in, even if there are differences between them. Jeez, my hand really isn't the way of a camera, isn't it? I'll maybe get this tripod extended just a smidgen. Got a lot of space in here today. A lot of space in here today. That's better. That's better. Kaido Fujimi just showed up, says hi, just call me Fuji. Like the cameras. Alphonse Jean has showed up, says hello. Hello, Alphonse, you are so dedicated. Well, that angle was not much better now, was it? I always see the top of my hand instead of the side. I'm actually rendering a video right now about fixing a really tricky problem with another thing, so you have that to look forward to. An actual edited video! Jesus Christ, I thought we're never going to do one of those again. I figured out how to fix those coin boxes that we were streaming the last time. And the repair turned into such a mess that it was no longer suitable for streaming, so I had to do it offline and make a video instead. That's an exciting fix in the opposite spirit of this, since it was rather difficult to get that working. Long story short, they have a software bug, and I've kind of worked around the software bug that the original manufacturer left in that product. Alphonse Jean says, what the fuck? It almost has a 4-minute delay. No, that's just me working and not paying attention to the chat. I am a man. I am not good at doing more than one thing at once. Haha, gender stereotypes. Oh, all of these solder joints are broken. Every time they melt, I just see how they do it in sections. And it's no good. Is any of these? No, they're not so broken that I can just rip them out. Sadly, but if I'd undone these joints before these, because the center ones seem to be worse off, I could have probably just desoldered one side of a resistor and ripped it out without desoldering the other one. Just because of how bad the solder joints were. Come on, we don't need to add solder or flux. We can do this, come on. We can't do this. We can't do it. We have to add just a tiniest bit of solder. There we go. So now we're just going to suck out all the old solder and solder everything back, I suppose. Nothing more to it. Brace for cow noises. We'll need to heat this through properly, because else we don't get the solder on the bottom side of the board, and that is contamination as well. I'm not going to take this board out of the frame because that's just a huge bother, since we are able to work solder from the top side for a repair this simple. Yeah, that's getting unsoldered beautifully. Yeah, I think we could probably be wise to preheat the board slightly. Ever so slightly. hold my hand here to make sure that I'm not overheating the capacitors. I really do not want to melt them. I just want to have a bit of base heat in the board to make it easier to melt the solder. Like so. That's just going to make the desoldering pump ever so slightly happier. Or not. That's quite a bit of solder here. So we need to use 2 irons to really heat it through. And that's a reasonably evacuated hole. I don't want to have to put solder on all of these, it's so annoying. Maybe a tad of flux is gonna make do. I'm just being lazy. Because adding solder means I have more solder sucked up into the desoldering gun and I have to clear it out sooner. And I don't want to clear it out, it's a bother. We'll check them with the light before we actually start installing the resistors, just to make sure everything's evacuated properly. That one did not evacuate properly. That's better. Okay, let's see. Let's see how this looks. I can see light shining through every single one of these holes. So they're going to be clean enough. I had to just put everything back. And then we're done. I have no possibility to power this up here, sadly. And since I don't have the rest of a gigantic industrial device here, and I don't know how to construct a test bed for this. But I'm quite confident in this. There's also a few other bad solder joints here that are a bit ugly from this board being removed in the past, so we're going to be redoing those as well while we're at it. Alphonse Jean asks, what is the device? It's some big motor control-y type thing, something magnetization, I don't know, I haven't seen it. Customer just said, hey, this shit ain't working. And I was like, okay, bring it over here. Also, do note for removal, I use the cheap, shitty solder. For reattaching, I'm actually using Crystal 400 6337, 3763, whatever you say. Alphonse Jean says, you said motor, but I'm sure the motor's connected to something. That's none of my concern. It's part of the beauty of doing this type of thing. You don't need to know what you're working on, as long as you fix it. Def Pumps Electronics and Repair asks, what is that thing? It's some kind of motor magnetization something. I'm not privy to what it actually is. All I know is it's broken and is here. And we found the problem. But what this thing, like, in particular is, it's a control board with like one giant IGBT on these screws here, and a bunch of terminals and a fan. So I guess you could call this like an IGBT power controller of some sort. It takes three-phase in and it puts something other than three-phase out. And it makes motor go happy. Marcel van der Broek asks, how are you going to test it? I'm not. I'm going to test it by handing it over to the guy who gave it to me, going, here, I think I found a problem, could you test it for me? And then he's going to test it and be like, yeah, it works, or he's going to bring it back and be all annoyed. This is not a MacBook. We do have fan spin, but sadly the fan has its own power transformer, so yeah. Doesn't really tell us much. Just 3 more to go. Then we have another 5 solder joints, and then I think we're done. A part of this job is being able to really listen to fault descriptions and really get people to tell you as much as they possibly can. You just need to press them for info. Like people hate me for that. I will just keep pressing my customers for information for like 20 minutes, an hour if I need to, just ask what exactly is going wrong, how did it behave, when were you there, what did you see, what weather was it hot, was it cold, all the info you can possibly get before you start working, because there could always be that little tiny bit of info that no one really thinks about, that tells the whole story. But when I first got this thing, they just said it doesn't work. We got an alarm. It wasn't magnetizing. Could you fix it? And I was like, okay, what's the problem? And they wouldn't tell me. And like three or four phone calls later, I figured finally got one of them to say, oh yeah, it's working for a while, but then it stops working. And if we had not known that, who knows if we'd seen this issue? Who knows if we'd started troubleshooting something completely different? But the fact that this thing works for a while tells us that the computer works, that the power supply works. The power supply is the usual issue on this particular machine, I know. So that just saves us so much unnecessary work, just getting good info from the customer. It's a bit silly that you usually have to hound customers to get that info. Like, people have a way to just see you as some kind of tech Jesus. They just go, here is module no work, you fix module. And that's just okay, I can work with that, but it's going to cost you. Much easier to just tell me all you know. I love hearing everyone speak. I love listening to all your industrial problems. That resistor moved while the solder on the other side was setting, so we need to refill the other side. There we go. I think the problem is solved now. I think this is going to work just fine when they put it back in use. We're not going to find out if that's the case for another while. But we have another few ugly things here to work with, because this has been field installed. And just look at that, it's no good. It's no good at all. It looks terrible. So I'm just gonna, they'll probably use some like 60 watt welder from the Stone Age to solder this in place. I should just get from a TS100. Yeah, what the hell kind of solder is that? Oh, they're trying to be green using lead-free. Yuck. Come on. Yeah, this is not good solder. Bad solder. Soldered badly. There we go. Yeah, that's just good enough. What's the chat say? Alphonse G says, lol, when someone say give me the tech Jesus, I always answer with selenal hand apposition and claim the problem is now fixed. That sentence breaks my brain. Okay. Let's just get this over with. Proper solder, proper iron. All you need is a 10-year-old OE 2901. This is probably the most profitable €100 I ever spent. That's better. Is it? It's soldered underneath as well. Is that just as bad? Yeah, it's not looking too good down there either, so I think we can actually fix that. Edward Hartman asks, are these spade terminals on the diode bridge crimped to solid copper wire which is then soldered to the board 2 centimeters later? Yes, they are. It's not... I mean, it's a reasonably good solution, I would say. I don't mind it. But it's not really soldered too well. Not down here either. So I'm just going to put some flux on there and redo it just to make sure it's good. There's a couple of them that don't really seem to have enough solder to make me happy. They should be filled to the brim. Filled to the brim. Fill her up, boys. Whoa. I've had burning my fingers off. We're installing fresh magic smoke in this. It's beautiful. Who said you couldn't put magic smoke back in? There we go. We didn't remove the solder joints up top. Let's wipe that off with a bit of alcohol and it's going to be good as new. No, you stay up there. Silly camera. Silly cheap tripod from like 1985. Q-tips. Now this is going to be hot as hell. Just going to evaporate my alcohol right away. And isopropyl fumes is actually really nasty to get in your face. It's not comfortable at all. So I want to keep some distance from this. Not super important to wipe this down. I just want most of it down, gone. And since I don't know what kind of fluxes in the solder they've used, I wouldn't want to have this board coming back with like a big corroded hole where the rectifier used to be. That would just be a bit unnecessary. Lovely. I think it's just rosin flux. Nothing too bad. There we go. She's done. What's it taken? Less than an hour. Someone says, looks like a board from the 70s or early 80s. I mean, we could possibly find a date code here. I think these are 2000s, definitely. I'm seeing a lot of 99s. Yeah. 1999. That's actually older than most of these. It's worked well. Although it has been in for service before, since the power supply has been renovated. But yeah, late 90s vintage. There we go. I'm not going to... well, yeah, I am going to fix this resistor over here, because that's part of a power supply circuit that very often goes bad, and I can see that it hasn't been resoldered before. Do we have sometimes a second one as well? I'm not seeing the second one, so we'll just give this the same treatment as the big ones. Just to be thorough. That is... it is a 220 ohm usually. No, 22 ohm, sorry. 22 ohm series resistor that's in series with a power supply for everything. And they run reasonably warm with the bigger boards that use this power supply, and they often just break the solder joints and fall off. And then when the solder joints on these start breaking, they kind of glitch a bit, make intermittent connections, and finally the switching IC and the switching transistor break, the board dies, and it comes back here. And I have to do a standardized power supply repair on these. So let's avoid that. Let's also make sure the series resistor is actually in good shape. Sometimes they start creeping up in value. I don't think this is one of those. 21.75 ohms, it's fine. I will put that back. Granen says, are those reefer capacitors? Yes, they are. Reefer capacitors aren't usually bad. They're actually a quality brand. It's just when you leave them sitting cold for a while, They tend to absorb moisture through the plastic, and when they fail, they don't usually fail in use. Roofer caps are, in my experience, reasonably reliable, as long as you don't let them sit for extended periods of time. Or if they develop like cracks, they're bad, but these are absolutely fine to go another 20 years. No problems. No problems at all. So I think that's gonna be the extent of the work we do on this board. I'm gonna check the solder joints on this connector, because that's just one of the standard issue things that fail on everything in the entire world, but they look okay. They don't usually fail on these particular boards anyway. No cracks on the switching transistor either, I don't think. No. We do have a freestanding TO220 here though. It looks good though, and they don't tend to fail on these anyway. So I don't think we're going to touch it, it's not worth our time. So yeah, we're done. This is, I'm 95% certain this board is going to work absolutely fine when we put it back in service, and the customer's going to be happy. It's going to be a cheap repair. Everyone's a winner. So yeah, I'm going to have to thank you guys for watching, and I'll see you around for the next thing, and look forward to a video on those coin boxes we streamed a while back. Now I need to figure out how the stop stream button thing works, because I wasn't just going to cut myself out randomly. So I'm just waiting for my arm to move in across, and I'm going to quit.